My dear students, today I am going to discuss coordinate geometry, the section formula. Before this, a few days back, I discussed the first formula, distance formula. Today, let us see what this section formula gives us. Now, consider these 2 points, x1, y1 and x2, y2. So, these 2 points, so let us call them point A and point B. So, coordinates of A, x1, y1 and coordinates of B, x2, y2. Now, this is the line AB joining them. Now, there is a point here P, whose coordinates are xy. Now, this P divides AB in the ratio M1 is to M2. That means AP by PB. AP by PB is M1, AP by PB is equal to M1 by M2. So, point P divides this straight line AB joining the points x1, y1 and x2, y2 in the ratio M1 is to M2. That means AP by PB is M1 by M2. So, this is M1, this is M2. Now, we have to find the coordinates of P, which are xy, in terms of x1, y1, x2, y2 and M1, M2. Now, today I am not going to show you the derivation of the section formula. That you can find in any textbook, which is not very difficult. Now, today I am going to show the practical application of this section formula. All right. Now, the formula is this. So, this formula gives us the coordinates of P, which are xy in terms of x1, y1, x2, y2 and m1 and m2. All right. Now, according to this formula, this value of x is m1 into x2 plus m2 into x1. So, m1 into x2 plus m2 into x1. So, m1 into x2 opposite, not m1 into x1, m1 into x2 opposite plus m2 into x1 divided by m1 plus m2. This is the coordinates of x according to this section formula. Now, what is value of y? So, this is the value of x. Now, what is the value of y? So, denominator remains same, m1 plus m2, and the numerator will be m1 into y2 plus m2 into y1. Again, I say not m1 into y1, it is opposite, m1 into y2 plus m2 into y1. So, m1 into y2 plus m2 into y1. So, x equal to m1 x2 plus m2 x1 by m1 plus m2 and y equal to m1 y2 plus m2 y1 by m1 plus m2. So, these are the values of x and y. So, we have got the point P. We have got the point P. Yes, you see, point P is this and this. So, this x value here and y value here. So, this is what is given by the section formula. All right. Now, there is a derivation from this formula. Now, suppose this P is the midpoint. Suppose P is the midpoint. If P is the midpoint, so let us see this P. Suppose P is the midpoint. If P is the midpoint, then AP will be 1, PB will be 1. That means AP equal to PB. If P is a midpoint of AB, then AP will be equal to PB. That means we can call them 1, 1. So, that means the ratio is what? 1, 1. So, if P is a midpoint, P divides AB in what ratio? 1 is to 1. Alright, that means M1 is 1 and M2 also 1. Then what will be coordinates? What will be the coordinates of X and Y, P? That means what will be the values of x and y. So using this formula, you see, if P is the midpoint, then what will be x? So M1, M2, that's a 1 and 1, so 1 plus 1, 2. 1 plus 1, 2, then M1, X2. So 1 into X2 plus 1 into X2 plus 1 into X1. That means X2 plus X1, that is X1 plus X2. Similarly, Y will be Y1 plus Y2. That means here in place of M1, M2, we write 1, 1. So 1 plus 1, 2, 1 plus 1, 2. And here M1 is 1, M2 is 1, so X2 plus X1, that means X1 plus X2, and here Y2 plus Y1, that means this. So these are the values of X and Y if P is the midpoint. So this is the midpoint formula. So what is P then? P will be this: X1 plus X2 by 2, comma, Y1 plus Y2 by 2. So this is the midpoint formula. So this one is the midpoint formula. All right. So section formula gives us the coordinates of a point which divides a straight line joining x1, y1 and x2, y2 in the ratio m1 is to m2. And if the P happens to be the midpoint, then coordinates of P will be what? This one. Okay. All right. So this is the thing, a section formula. Now let us see some application, practical application of this formula. Okay. Practical application means some numerical sum where you have to apply this formula. Now consider this straight line AB which joins these 2 points, 3, 4 and 5, 7. So this point is suppose 3, 4 and this point is 5, 7. And P divides in the ratio 3, 2. So this is point P which divides the straight line in the ratio 3:2. So this point is 3, 4, this point is 5, 7, and this line joining these 2 points is divided by P in what ratio? 3:2. So M1 is 3, M2 is 2. Now what are the coordinates of P? So the question is, find the coordinates of P which divides this line in the ratio 3:2. Then using this formula, see what you can do. So what will be value of x using this formula? X will be what? M1 plus M2, that means 3 plus 2. 3 plus 2. So M1 x2. M1 x2, that means 3 into 7. So again that word opposite, not 3 into 3. It is 3 into 7. 3 into 7 plus 2 into 3. 3 into 7 plus 2 into 3. This is the value of x. And what is the value of y? Again 3 plus 2 denominator and numerator 3 into 1 minute, sorry. This is 3 into 5. 3 into 5, 2 into 3. 3 into 5, not 7. 3 into 5, because we are finding x coordinate. 3 into 5 plus 2 into 3. 3 into 5 plus 2 into 3. Okay. Now for y coordinate, 3 into 7 plus 2 into 4. 3 into 7 plus 2 into 4. All right. So what do you get x equal to? So here 5 and 15, 15, 6, 21. 21 by 5. And then what is y equal to? So 5 and 21, 21 plus 8, 29. So x value is this, y value is this. Therefore, what will be the coordinates of P then? Coordinates of P will be 21 by 5, 21 by 5, 29 by 5. So this is the answer. So the question was what? To find the coordinates of P which divides the line joining these 2 points in the ratio 3:2. So the coordinates of P are this: 21 by 5, comma 29 by 5. So we have used the section formula. Okay. All right. Let us see another So involving minus sign. So here there is no minus sign. So let us see another involving minus sign. For example, suppose this line joins these 2 points, minus to 5. So this is minus to 5, this point, and that point is 6 minus 1, 6, 6. This point is 6 minus 1. And P divides, the point P divides it in the ratio 4:3. This P divides in the ratio 4:3. So P divides this straight line joining this point and this point in the ratio 4:3. Now we have to find coordinates of P. So coordinates of P we have to find out. Alright. So what will be value of x? Yes, again that opposite rule. So coordinates of x will be, now 4 plus 3 denominator will be 7. Okay. Now 4 into 6, 4 into 6, 24, plus 3 into minus 2, that is minus 6. See opposite, 4 into 6, not 4 into minus 2, 4 into 6, 24, plus 3 into minus 2, minus 6. That means what do you get? 7, and then 24 minus 6 is what? 18. 18 by 7. Alright, so this is value of x. And what is value of y? So 4 plus 3 as it is. Again opposite, 4 into minus 1. 4 into minus 1 is minus 4. Plus 3 into 5, 15. So then we get is 11 by 7. So 11 by 7. Alright. Therefore, what is this point P? Therefore, P will be, so P will be what? 18 by 7, comma 11 by 7. So this is the answer. So we have found the coordinates of this one. So coordinates of P what? X value this one, Y value this. So coordinates of P will be this 18, 7, then 11, 7. So we have used section formula to find the coordinates of a point which divides a certain line joining two certain points in a given ratio. Okay. Okay, now let us see. Okay. Now let us see a slightly harder one. Now this is a straight line which joins these 2 points. These 2 points are given 2 minus 2 minus 7, 4. 2 minus 2. This point is 2 minus 2. And the other point is minus 7, 4. This point is minus 7, 4. Now the question is, we have to find the points of trisection of this line. Points of trisection, that means the 2 points which divides this straight line in 3 equal parts. So this point P, this point Q. Now P and Q are 2 points which divides this straight line in 3 equal parts. So this part is equal to this part is equal to this part. Suppose you call this point A, this point B. That means AP equal to PQ equal to QB. AP equal to PQ equal to QB. So these 3 parts are equal. So P and Q are called points of trisection. P and Q have trisected AB. That means have divided AB in 3 equal parts, in 3 equal sections. This is the first section, second section, third section or parts, and these 3 are equal. Now we have to find out coordinates of P and Q. That is the question. All right. So again, let me say, what is the question? The question is to find the points of trisection. The question is to find the points of trisection of AB. The points of trisection of AB. All right. Now let us see. Let us say P and Q are the points of trisection. Now, first of all, let us find out the coordinates of P. Let us find out coordinates of P. Now, for the time being, you forget Q. Suppose Q is not there. Just forget Q. For the time being, forget Q. Now, AP by PB will be 1:2. So, what will be AP is to PB? Definitely it is 1:2. So, this part is 1, this part is 2. So, 1:2. So, P divides AB in what ratio? 1:2. So, this is 1, this part is 1, this part is 2. So, point P divides AB in what ratio? 1:2. So, for the timing you forget Q. Alright. Now, let us find out coordinates of P. So, coordinates of P will be what? Using section formula, denominator will be 1 plus 2. Again, here also, denominator will be 1 plus 2. Alright. This is x coordinate, this is a y coordinate of P. Then that opposite rule. So, x coordinate of P is what? 1 into minus 7. 1 into minus 7. 1 into minus 7 is minus 7. Plus 1 into minus 7 plus 2 into 2. 2 into 2 is 4. So, opposite 1 into minus 7 plus 2 into 2. Okay, 1 into minus 7, 2 into 2, 4. Then for y coordinate, 1 into 4, 1 into 4 is 4. Plus 2 into minus 2, 2 into minus 2, 2 is minus 4. So, for y coordinates, what you do? 1 into 4. 1 into 4, 4 plus 2 into minus 2, minus 4. So, now this part is what? 3 and this is minus 3. And this part is what? 3, 0. So, coordinates of P is what? Minus 3 by 3, minus 1, 0. So, this is the answer. Coordinates of P what? Minus 1, 0. So, P is, we got minus 1, 0. Okay. So, coordinates of P minus 1, 0. Now, let us find out coordinates of Q. So, Q was here. So, this was Q. Okay. Alright. Now, for the time being, you forget P. If you forget P, the straight line will be like this. You see, this is A, this is B, and Q is here. So, now this ratio will be 2:1. So, forget P for the time being. So, AQ is to QB. So, what is AQ is to QB? Definitely this from here to here to 2:1. Now, the ratio is 2:1. And what are A? A is 2, minus 2, and B is what? Minus 7, 4. B is minus 7, 4. So, A is 2 minus 2, B is minus 7, 4, and Q is here. So, the ratio is 2:1. Now, let us find out Q. So, let us find out the coordinates of Q. So, what will be Q then? Again, so this is okay. So, 2 plus 1 this time, 2 plus 1, 2 plus 1. Because the ratio is 2:1, so denominator will be 2 plus 1, 2 plus 1. Then that opposite rule, 2 into 2, 2 into 2, 4. 2 into, sorry, that opposite rule. 2 into minus 7, 2 into minus 7 is minus 14. Opposite rule, not 2 into 2, but 2 into minus 7. 2 into minus 7 plus 1 into 2. 1 into 2 is 2. 2 into minus 7 minus 14 plus 1 into 2. 1 into 2 is 2. And for y coordinates, 2 into 4. 2 into 4, opposite. 2 into 4, 8. Plus 1 into minus 2. 1 into minus 2 is what? Minus 2. So, for y coordinates, what you do? 2 into 4. 2 into 4, 8. Plus 1 into minus 2, minus 2. So, what will be coordinates of Q then? This is 3, comma, this is also 3. So, what is that? Minus 12. Minus 12, this is 6. So, that means Q is what? Minus 4, 2. So, these minus 4, 2 coordinates of minus 4, 2 coordinates of Q. So, what is Q? Q what? Minus 4, 2. So minus 1, 0 and minus 4, 2. So we have found coordinates of P and Q. So the question was find the coordinates of the points of trisection. So P and Q are the points of trisection of this line AB joining these 2 points, and we have found the coordinates of P and Q as minus 1, 0 and minus 4, 2 using what? Section formula. Alright. So in the first case we took the ratio what? The ratio was 1:2, and now here when to find Q, ratio is 2:1. So that is the answer. Okay. All right. Let us see another now. Let us see another. Yes, again, say points of trisection. Let me show another example. Points of trisection, where this time I will use a slightly different method. Slightly different method. Again, points of trisection. So this is the line joining the 2 points, 3, minus 2. This is 3, comma, minus 2. And this is minus 4, 6. Minus 4, 6. All right. So this straight line joins 3, minus 2 and minus 4, 6. So the question was like before, find the points of trisection of this line joining these 2 points. So suppose again the points of trisection are P and Q. So this P and Q are the points of trisection. That means suppose we call it A and this we call it B. So AP equal to PQ equal to QB. All right. So 1:1, 1, 1. So 3 parts equal. 3 parts or section. This is why it is called section formula. All right. Okay. 3, minus 2 and minus 4, 6. Yes. Now you see. So now let us see this line. So for the timing you forget Q. So this is a 3, minus 2. This is a point P, minus 4, 6. And this is a point P, whose coordinates we have to find out. Point P whose coordinates we have to find out. Now this part is 1, this part is 2. So for the time being, forget Q. So this is 1, this is 2. So 1:2, right? Therefore, what will be P? What will be P as I showed you before? So what will be P? 1:2 minus 4 minus 4 plus 2 into 3, 6. X coordinate below 1 plus 2, 3. Okay. Then here also 1 plus 2, 3. 1 plus 2, 3. For Y coordinate 1 into 6, 6 plus 2 into minus 2, minus 4. All right. So what do you get? P equal to the coordinates of P 6 minus 4, 2. 2 by 3. 2 by 3 and 2 by 3. 6, what do you get? 2 by 3. And this also 6 minus 4, 2 by 3. 2 by 3, 2 by 3. Is it so? 2 by 3 and 2 by 3. Yes. So this is P. So what is P? We got now 2 by 3, comma 2 by 3. So coordinates of P we have found out. Now next we have to find out coordinates of Q. Okay, now let us see this diagram. For the time being now you forget P. To find P we forgot Q. We forgot Q to find P. Now to find Q, so now you see we'll do a slightly different method as I told you. Yes. Now we have to find Q. Now you forget this part. This is another method. Just forget this part. Now concentrate on PB and Q. Now see, Q is the midpoint of PB, isn't it? So this part equal to this part. Therefore, what is Q? Midpoint of PB. Now we are going to use midpoint formula to find Q. You followed? So we'll use that derivation, that midpoint. Q is the midpoint of PB. You see. So for the timing, you forget A. Forget that part. Concentrate on P, B, and midpoint Q. So what will be Q then? So what will be Q? Q is the midpoint of PB. Therefore, we can use that midpoint formula. Midpoint formula, you see. Now, midpoint, what was the formula? X1 plus X2 by 2, isn't it? So, X1 plus X2 by 2 and Y1 plus Y2 by 2, isn't it? Now, X1, this is X1, this is X1, this is Y1, this is X2, this is Y2, all right? X1 plus X2 by 2, that means 2 by 3 plus minus 4. 2 by 3 plus minus 4. X1 plus X2, 2 by 3 plus minus 4 by 2. Then for Y coordinate, Y1 plus Y2 by 2. So Y1 2 by 3, 2 by 3 plus 6 by 2. So say using the formula, midpoint formula, X1 plus X2 by 2, Y1 plus Y2 by 2. X1 plus X2 by 2, Y1 plus Y2 by 2. That is how we are going to find Q using midpoint formula. So Q equal to, this is 2, now refute this LCM 3, so minus 4, minus 12, minus 12, so minus 10. So that part you can work out, don't make mistake. 2 by 3 plus 2 by 3 minus 4, so minus 12, 2 minus 12 is what? Minus 10, minus 10 by 3 by 2, and this point 2, then here 18, 20 by 3. So 3, 6, 18, 18 plus 2, 20, 20 by 3. Okay. Now the question of simplification. Up to here, section formula. Now just a matter of simplification. So now what do you get? This one, 2, 3, 6. So 6 minus 10. Minus 10 by 6. Minus 10 by 6. And this one you get 20 by 6. So minus 10, 3 into 2, 6. 20, 3 into 2, 6. So now this one will be what? 3 minus 5, comma 3, 10. So this is the answer. This is the coordinates of Q. Minus 5 by 3 and 10 by 3. So we have got P, this one, and we have got Q. And this time we found out Q by what formula? By using midpoint formula. Is it clear? All right. So this is a question of finding the points of trisection of a straight line joining two given points. Okay. All right. Now let us see coordinate geometry and geometry combined. So a question which combines coordinate geometry and general geometry. Okay. Yeah, this question. Show that the points taken in order form a parallelogram. Now say these points are given. A given 1, 2 and B given 4, 3. C given 7, 6 and D given 4, 5. So these 4 points are given. Coordinates of A 1, 2, coordinates of B 4, 3, coordinates of C 7, 6, coordinates of D 4, 5. So the question is, show that these 4 points taken in order form a parallelogram. The parallelogram will be ABCD. That is why taken in order. First point, second point, third point, fourth point. ABCD, you have to prove ABCD is a parallelogram. So this is the question. These 4 points are given. The question is, prove that these 4 points are vertices of a parallelogram. That means to prove ABCD is a parallelogram. Okay. All right. Now let us see how we can use this coordinate geometry to solve this geometry problem. Okay. Now see parallelogram. Now taken in order, that means A, B, C, D. Not A, B, C, D, taken in order, A, B, C, D, clockwise or A, B, C, D, anti-clockwise. Either clockwise, I have taken clockwise. You can take it anti-clockwise also, A, B, C, D, but taken in order, all right? Now you have to show these 4 points. A is 1, 2, A is 1, 2, B is 4, 3, B is 4, 3, C is 7, 6, and D is 4, 5. All right. So you have to show these 4 points are the vertices of a parallelogram. Now we have to use one important property of parallelogram. In a parallelogram, the diagonals bisect each other. So you see AC is a diagonal, BD is a diagonal. Now AC and BD bisect each other. So that is the important property of parallelogram, and that property we are going to use. Suppose AC and BD, these two diagonals meet at O. Now if we can prove that O is the midpoint of AC and also O is the midpoint of BD, then work is done. Suppose we can prove O is the midpoint of AC and also O is the midpoint of BD, then what we can say? We can say AC and BD bisect each other at O. Therefore, ABCD is a parallelogram. So that is what we are going to do. We are going to show O is the midpoint of AC and also O is the midpoint of BD. All right. Okay. Now suppose, now let us, now here we have to use the midpoint formula. Okay. Now, yes, midpoint of AC. So, midpoint of AC. Now, midpoint of AC is what? Midpoint of AC. Yeah, so using the midpoint formula, what will be midpoint of AC? X1 plus X2 by 2. So, 1 plus 7 by 2. 1 plus 7 by 2. That is the X coordinate. And what will be the Y coordinate? 2 plus 6 by 2. 2 plus 6 by 2. So midpoint of AC midpoint will be 1 plus 7 by 2 and 2 plus 6 by 2 plus 6 by 2. All right. That means 7 plus 8, 4 by 2, 4 and 4, 4. Yes, you see. So this is a midpoint of AC. Midpoint of AC is 4, 4. Clear? Now let us find out midpoint of the other diagonal BD. So midpoint of AC we have found 4, 4. Now let us find out midpoint of BD. Using the same formula, let us find out midpoint of BD. So what will be the midpoint of BD? You see, again using the same formula. Okay. BD. So 4 plus 4. 4 plus 4 by 2. So 4 plus 4 by 2. And then 5 plus 3 by 2. 5 plus 3 by 2. Okay. So midpoint of BD. Midpoint of BD will be what? 4 plus 4 by 2 and 5 plus 3 by 2. So this is what then? So 4 plus 4 by 2. That means 8 by 2, 4. And then 8 by 2, 4. 8 by 2, 4, you see. Yes. Did you get it? See. So midpoint of AC is 4, 4. So this point is what? This point, midpoint of AC, 4, 4. Midpoint of AC is 4, 4. And then midpoint of BD also 4, 4. You see, the same point is midpoint of both the lines. That means AC and BD bisect each other at O. So you see, midpoint of AC is this, midpoint of AC is this. These two are same points. Now the same point is midpoint of two lines. That means those two lines are bisecting each other. So from this, what we conclude? We conclude AC and BD bisect each other. So what we conclude? AC and BD bisect each other. And therefore, ABCD must be a parallelogram. Because in a parallelogram, diagonals bisect each other. So in order to prove this parallelogram, we have used the important property of parallelogram that diagonals bisect each other. You follow? Okay, so this is one way. Then the last one for today. Yes. So I am trying to discuss some these common questions which are frequently given in exam. Okay. Now this one. If the line joining -1 and -1, 4, -1, 4 and 7, 8 and 7, 8. If the line joining this and this and the line joining minus 2, minus 3, minus 2, minus 3 and xy bisect each other, find the values of x and y. So x equal to what? Y equal to what? That is the question. So the line joining these 2 points and the line joining these 2 points bisect each other. The question is this: the line joining these 2 points, suppose we call it AB. So this is point A, this point B. And suppose this point C, this point D. So line joining these 2 points, that means AB, and line joining these 2 points, that means CD. So AB and CD bisect each other. AB and CD bisect each other. So this is AB and this is CD. So AB and CD bisect each other. It is given. So you have to find the values of x and y. You have to find the values of x and y. So what are the values of x and y? All right. So A is what? A is minus 1, 4. A is minus 1, 4. And B is 7, 8. B is 7, 8. Then C is minus 2, minus 3. Minus 2, minus 3. And D is xy. So it is given A, B and C, D bisect each other. All right. So you have to find the values of x and y. All right. So you can use the midpoint formula. So since AB and CD bisect each other, so their midpoints must be same. All right. So what is the midpoint of AB? Midpoint of AB. Midpoint of AB will be what? Midpoint of AB will be what? This will be 2. This will be 2. So minus 1 plus 7. Minus 1 plus 7 by 2. Then 4 plus 8 by 2. 4 plus 8 by 2. That means this is what? 7 minus 1. 7 minus 1, 6. 6 by 2, 3. 3. And this is 12, 3, 6. So this is the midpoint of AB, 3, 6. Now let us find out midpoint of CD using the same formula. All right, midpoint of same formula. Okay, so what do you get? So again, this will be 2, 2, midpoint formula. So minus 2 plus x. Minus 2 plus x by 2. Minus 2 plus x by 2. Then minus 3 plus y by 2. Minus 3 plus y by 2. Now x and y values we do not know. So we have to find out x and y. All right. So x minus 2 by 2, then y minus 3. Okay. So this one we can say this one. Yes. So you see, midpoint of AB is this one. And midpoint of CD is this one. Now since they bisect each other, therefore they have the same midpoint. That means this equal to this. Okay. So since they bisect each other, since AC and BD bisect each other, therefore they have the same midpoint. Their midpoints are 1, not 2. So that means this equal to this. So therefore what? Since these two AB and CD bisect each other, so this point and this point same. That means this is what? X minus 2 by 2. X minus 2 by 2, comma, y minus 3 by 2. Y minus 3 by 2. This point is same as which point? 3, 6. So you see, this is the thing. So these 2 points are exactly the same point. Okay. So this gives us what? Yes. So this equal to this. So x minus 2 by 2 equal to 3. So this coordinate equal, that means suppose xy equal to, suppose, PQ. If this xy, this point and this point same, then x must be equal to P, y must be equal to Q. That is the principle. So x equal to P, y equal to Q. So like that, you see. So here we get this equal to this equal to this, and what this y minus 3 by 2, that is equal to 6. Now if this is 3, what do you get? 3 to the 6 plus 2, x equal to 8. So this is a matter of solution. So x minus 2 equal to 6, so x equal to 6 plus 2, 8, x equal to 8, and this one gives us what? Y equal to 6 plus 3, 9. So y equal to 9. 6 plus 2, 12, 12 plus 3, 15. So if you cross multiply, y minus 3 equal to 12. So 12 plus 3, 15. 8 and, what is that? 8 and 15. X equal to 8, y equal to 15. So this is the answer. Finally, what we get? X equal to 8, y equal to 15. This is the answer. So the question was, find the values of x and y. Find the values of x and y. So this straight line and this straight line bisect each other. Find the values of x and y. So we got the values of x and y. X is 8, y equal to 15. So you see, today I discussed the section formula and then a few application of this formula. Okay, so in my next video, I'll try to see some more numerical example to show application of this formula. Okay, for today, and please don't forget to subscribe to my channel if you have not done it yet. Okay, so if you like my teaching, try to subscribe and share. Okay, thank you for today.